Hello friends, we start with our next theorem known as Tellegens Theorem. We have already completed superposition theorem, Thevenin's, Norton's, maximum power transfer, reciprocity, Millman's. So this is our next class of theorem. This is again one of the important theorem, and in my previous video we have already gone through the concept which is applicable in Tellegens Theorem. So if you find all those theorems useful to you, please subscribe my channel, please share it, please comment it. Once you share with your friends and subscribe it will be more easy for you to go through my all videos, and it will be more helpful to all of you. So please subscribe my channel. We start with our next theorem known as Tellegens Theorem. Okay. So Tellegens Theorem states that in any network, if this is a network, so Tellegens Theorem states that in any network, the algebraic sum of power p for n number of elements starting from say I equal to 1 to n is 0. Very important thing, the statement of a Tellegens Theorem. Okay, the statement of a Tellegens Theorem, that is the summation of power in a network with different elements connected, and if you find the algebraic sum of all those power in a network, so that is equal to 0. So this is all about the Tellegens Theorem. And if you remember, in our previous video, in our previous sessions, we have already discussed about this concept, that is in the concept of power. So there itself also I have explained about the summation of algebraic sum of power in a network is 0, and the same thing is applicable, and this is known as Tellegens Theorem. Now the important thing is Tellegens Theorem is applicable for linear, okay, non-linear, bilateral, unilateral, okay, or you can say time variant, time invariant, so this theorem is applicable under all circumstances. Okay, so this is known as Tellegens Theorem. Yes, one more thing, lumped networks, this we have already studied. So yes, Tellegens Theorem is applicable for all type of situation. That's why the algebraic sum of power within the network is 0. So the Tellegens Theorem is applicable. Very important thing. Okay, so this is all about the statement of Tellegens Theorem. We will try to understand this theorem using one problem. Okay, we'll see one problem, and through that we'll understand what is Tellegens Theorem. With the help of Tellegens Theorem, sometimes you have to find the value of voltage as well as current. Sometimes you have to find the value of resistance. So by using this theorem, you can find any parameter in the network. So always keep in mind that the summation of power in a network is 0. That is, algebraic sum of power in a network is 0. We'll see through one problem. So friends, this is our problem. Here are the impedance known as Z1, Z2, Z3, Z4, and here is the voltage source V0, generating current I1. The voltage appearing across here is V1, here it is V2, here it is V3, here it is V4, and there are the currents flowing in the network. Now you have to find the algebraic sum of power, that is Pi, starting from I equal to 1 to say n is 0. This we have to analyze. Okay, so for this network, if I say V1, V2, V3, V4, and this is V0, so what is the algebraic sum of power in this network? What is the algebraic sum of power in this network? So you can say that power because of P0, because of V1, V2, V3 and V4. So here are power known as P0, then P1, then P2, then P3, then P4. So as per convention, P0 plus P1 plus P2 plus P3 plus P4 will be 0. Okay, so now we have to find the value of P0, P1, P2, P3, P4. Now please see, if I find the value of P0, see one by one we will find all the values. If I find the value of P0, first I am finding this value. Okay, this value. So the value of P0 is what? It is V0 into I1. Now if I talk about the power V0, the nature of power across V0, so it's a kind of power which is supplying to the entire network. Why? Because current is going out from this voltage source, that means it is supplying, so the power sign comes to be negative. The value of V0 is 10, so it is 10 into I1 is 5, so that comes to be minus of 50 watt. Okay, so this is the value of P0. It means this source is supplying power to the network. Okay, this we have already discussed, just try to revise it. Okay, if we talk about P1, the P1 is the power is what? It is V1 into I1. Now this power is positive. Why? Because this element is absorbing. Okay, because current is entering into this terminal, and the value of V1 is 6 into the value of I1 is 5, so it is positive, that comes to be plus 30 watt. This is P1. Now if you talk about P2, this again current is entering into this terminal, that means it is absorbing the power, so that comes to be V2 into I2. The value of V2 is what? That is 4 into the value of I2 is what? That is 2. This is a positive power because it is absorbing, so that comes to be 8 watt. So this is the value of P2. Okay, now we will find the value of P3. Now we will find the value of P3. I will just write here the value of P0 as I am just writing here. The value of P0 we have find as minus of 50 watt. The value of P2 we have P1 we have find as 30 watt. The value of P2 we have find as 8 watt. Okay, I am just rubbing it. Now we find the value of P3. So P3 is what? Again P3, you see current is entering, so this is your power. The sign comes to be positive because it is absorbing. The value of V3 is 3 into I3 is 3, so that comes to be plus of 9 watt. This is the value of P3. If you talk about P4, so that comes to be V4 into I4. Now if you see V4, this is your voltage V4. The value of V4 is 1 volt. Again current I4 is entering, so that comes to be plus, it is 1 into 3, so that comes to be plus of 3 watt. Okay, so if you find the summation of all these powers, which one? This one, this one, this one, this one, and this one. Okay, so if you do it, so what will be the answer? The answer, that is P0 is how much? It is minus of 50 watt plus P1 is 30 plus 8 plus 9 plus 3. So that comes to be how much? It is 0. Okay, it is 0. So with this we have understand, yes, in a network the algebraic sum of power is remains 0 independent of the nature of the network. So this is all about the Tellegens theorem. Okay, so okay friends, we move on with the next problem under Tellegens theorem. This is a problem in which you have to find the value of Ix using Tellegens theorem. See, you can simply find the value of Ix also, but here we have to find the value of Ix using Tellegens theorem. So we will see how we find the value of Ix. So As we have to find the value using Tellegens theorem, that means we have to apply the concept that is summation or algebraic sum of power. Okay, so that is what? 0. Starting from say I equal to 1 to n. So the summation of power within the network is 0. So now you see here are 3 elements A, B, C. We don't know what is that element. Simply we have given A, B, C. Similarly, this is a current source, this is also a current source, and this is a voltage source. Now what I will do, I will consider the power across all the elements. Say it is PA. I will just mention it. I will just consider power by some different color. So this is PA. I say that it is P2. Okay, or you can say it is P1. This is PB. This is P3. This is P2, and just say it is PC. So 1, 2, 3, 4, 5, 6. So you can say that as per the concept of Tellegens, PA plus P1 plus P2 plus PB plus of PC plus of P3 is what? 0. Okay, so this is the concept of Tellegens. So now applying this concept, you have to find the value of current Ix. So one by one we will see what is PA, P1, P2, PB, PC and P3, and based on this we will find the value of Ix. So first of all we will talk about PA. Now see, very important, we will see all the powers one by one. If you talk about PA, now see PA. Now very important thing, this PA is some element, current is here 1 ampere. Now we don't know voltage, so what is the voltage? Now see, 25 voltage is appearing across these two nodes. So the same voltage will be appearing across this element. So the nature of this voltage is what? It is something like this. Okay, and the value is what? It is 25 volt. Very important. So you can say that the current is entering, that means this element is absorbing the power. This element is absorbing the power. So you can say that what is the voltage here is 25 volt into the current is 1, so that comes to be 25 watt. Now since it is absorbing, the sign convention comes to be plus of 25 watt. Okay, now if you talk about PA is over, now come to P1. First of all we will talk about P1. So P1 is what? Again the voltage is 25 and the current is 5 ampere. Now current is coming out from this positive terminal. It means this current source is basically delivering the power to the network. So that comes to be minus of 125 watt. This is P1. Okay, very important. Now come to the next, that is P2. We'll talk about P2. See, where is P2? Yes, this is P2. The current is what? Ix. The voltage is 10 volt. So it is 10 into Ix. Now you see, again this source is delivering the power because current is going out from this node. So that comes to be, it is minus of 10 Ix. Okay, so this is delivering power to the network. Now P2 is over. Now come to what? PB. Okay, PB is the power is what? Please see, this is the 15 volt source. So whatever the current Ix here in the branch will be here in this B element also. Why? Because it is in series. So that comes to be 15, that is voltage, and current is Ix. But again this current is also going out from this positive terminal. That means it is also supplying power to the network. So PB goes negative. It is minus of 15 Ix. Okay. So P1, PA, P2, PB over. Now come to PC. If we will talk about PC, PC is what? This is 15 volt. Okay, it is 15 volt. 2 is the current which is coming towards this. It means this element is absorbing the power. So PC comes to be how much? How much it is? Plus of 13 watt. This is all in watt. Okay, this is all in watt. PC is also over. Now come to the next, that is P3. So what is P3? Again 2 ampere is entering. So it is 10 into 2, that comes to be 20 watt, and it is plus. Why? Because it is absorbing. Okay, so with that you can finally find the power PA, P2 PB, P1, PC and this. So now can you find the value of Ix? Yes, very simple, we will find the value of Ix. So the value of Ix comes to be what we will find here. Please see. It is what? It is PA, that is 25, P1 it is minus of 125, then P2 it is minus of 10 Ix, then it is PB minus of 15 Ix, okay, then PC it is plus of 30, okay, then what? PC, then P3 it is plus of 20, that comes to be 0. So how much it is? 50, 75 minus 125, that is 25 of Ix. So 25 of Ix comes to be minus of 50. So Ix comes to be minus of 2 ampere. Very important. So from here we have find the value of Ix by using the concept of Tellegens theorem. So this is one question in which we have understand how we apply the concept of Tellegens theorem and how we find the value of current Ix. Okay.